for inviting me. It's really a pleasure to be here to talk about agriculture, the technologies application agriculture at that time. My name is Floyd Nicola. Currently, I serve as an assistant professor of agricultural water management at Oregon State University and the Department of Biological and Ecological Engineering. My work basically focuses on irrigation use efficiency as well as groundwater recharge and groundwater quality through applied research and stakeholder driven solutions. Specifically, I studied some contaminants such as nitrate leaching, evapotranspiration, and also I use different technology, machine learning, and process based models, as well as remote sensing to help producers and water managers use water more efficiently. Also lead efforts and outreach in a certain way to try to bridge what's happening in science with practical applications in the field. Such for some background about myself, originally from Haiti. I'm an agricultural engineer, so I grew up basically in the farming settings where I used to go to the field in Haiti. It's different to the US. We don't have those big agricultural field, but we have some work crops like corns and beans that I know about. And I have a bachelor's degree in agricultural engineering. And following my bachelor's degree, I work for several NGOs as a GIS specialist, and I also work for the Haiti Ministry of Agriculture as a GIS specialist and site engineer. And after my experience in Haiti, I moved to Florida, where I earned my a master's degree in agricultural and biological engineering. And over there, I did some research on evaluating the impacts of climate change on rice yield in Haiti, and also as developing a model that simulates potential adaptation strategies to reverse the negative impacts of climate change. After my master's, I moved all the way to the West Coast in California, where I earned my PhD in biosystems engineering at UC Davis. Over there, I work on several projects that include crop modeling, irrigation use efficiency, as well as evaluating the impacts of nitrate leaching and salinity on irrigated agriculture and groundwater sustainability. Basically, what I did do is I used field experiments and field monitoring to collect data to develop model. First of all, that model evaluate what are the conservation practices that are able to reduce nitrate leaching from contaminating the groundwater resources in the Central Valley, and also develop a comprehensive decision support systems. It's basically that modeling framework predict both crop yield and economic returns, considering which type of crop the growers or the farmers would like to grow. And what we did with that modeling framework, because as you know, what's happening when you have model, they are not always accurate, and farmers they need tools that can help them to make better decision. So we basically take that modeling framework and we implement it into a user friendly decision support systems with two different purposes. The first purpose is to help the growers to make better decisions in terms of salinity management. For example, the growers can use the tool to choose which crop to grow for the next seasons because they will know if they choose to grow almond or pistachios, how much money they will be able to make considering the soil type and the irrigation water quality. And the other purpose of that decision support system is that the policymakers can use it too. For example, salinity is a huge problem in the Central Valley, and the state was looking on how to identify part of the valley that is not able is no longer suitable for agricultural production. So it's basically they can use that tool and select some area that any crop you grow because of soil buildup issue, you wouldn't be able to have a viable economic returns, and they can retire that part of just repurpose that part of land and do other stuff instead of doing agriculture. And yeah, following my experience, I graduated last year with my PhD in biosystem engineering, and I work slightly as a project engineer and consultancy, where we basically develop a model that characterizes the contribution of nitrate leaching not from agriculture, but from poultry, from feedlot. And I also try to set up an experiment trying to use new technology like OpenET and leverage it with cover crops to see how the combination can reduce runoff at field scale. And currently, right now, I'm a professor at Oregon State University, and I am part of a team that we call Agriculture Water Technical Assistance Program, where we are a team of scientists. We have hydrologists, we have sociologists, anthropologists, and engineers. We are trying to coordinate efforts to help water managers, growers, and policy makers in the state of Oregon to use water more wisely. Yeah, that's a wonderful question. And if you look at the evolution of technology right now and with machine learning, and if we were to consider the large language models, the LLM, and I think right now, in terms of precision irrigation, I'd say it's mostly data driven decision making. For example, agriculture consumes about 70% of the world's water. So therefore, if we want to make smart irrigation by using data either from soil moisture sensors, weather data, remote sensing, automation, and very advanced algorithms, or also digital irrigation, I think we can say we can produce more yield with less water. For example, there have been studies where we use a combination of soil moisture sensors with a base controllers where we reduce water by up to 50% in agriculture and landscaping. And the other platform I would say it's the large language model, which it's basically those emerging platforms that pair machine learning with focus with conventional that combine those machine learning models with conventional practices. And also it provides ours a user-friendly interface where they can ask questions, for example. Imagine that growers that has access to an LLM and want to plan irrigation scheduling for its field. They can really ask, I'm going lavender, for example, what could be I'm living, let's say, in central Oregon, and I have 24,000 square meters of field, and that LLM will take data from existing sheets. It will consider the location of what type of soil, and it will look at, for example, what is the historical evapotranspiration and provide recommendation. And another approach is also the combination of process-based model and machine learning and AI-based machine learning models that can also improve the efficiency. For example, there was a project when we were looking at data assimilation into a process-based model in the Central Valley of California, where we were feeding the model with leaf area index data and soil moisture data on a weekly basis, and the model just predict how much water to provide in the following week. And we were able to produce the same yield with 30% less water, which makes that growers can save money and also can. That's a very good question because even though agriculture is being driven by yield and profit, but we have to look at what are the environmental impacts, right? And with the growing populations and with with the volatility of the climate, there is a growing demand of fresh water, and also there is overuse because of not very good conservation practices or management practices. For example, the global water demand is projected to rise by 30% in the next couple of years, right? And also because the fresh water is not enough, there is also intensive use of the groundwater, the pumping of the groundwater that lead to depletion, and we can see that's happening in Kansas and Uganda aquifer or in the Central Valley of California. Now, with those technologies, what we can do is to develop those modeling framework, use those algorithms and apply them into user-friendly platforms where they are easy to use by farmers, by growers. And by that, they can improve their management practices and grow crops sustainably. And because in some other developed countries, there is also the regulatory and policy pressures. For example, in California, we have the stigma that basically requires farmers to comply with a lot of regulations in terms of groundwater recharge or in terms of groundwater quality. They have to use management practices that reduce the leaching of the nitrogen into the groundwater. And also sometimes and also if you see the changes and the climate, sometimes the farmers, they don't have the same water that they used to have. That's what's happening, for example, in Central Oregon, where in the last couple of years, because of the drought, the farmers, they didn't receive the same water they used to have, the same amount of water they used to have. So therefore, the use of technologies, as I said, moisture sensors, the monitoring of the water content in the soil, the use of water controllers, and the use of soil health metrics. And I think that by developing those decision support system and also by doing extension and outreach, because sometimes we have those technologies. And now the question is how to convince the growers or the farmers to use those technologies. And we have to show them this is accurate. You will make more money. You will make more money. You will use less inputs and makes more money and increase your yield per hectare or per acre. So we can encourage the growers, basically the direct users, to use those technologies. And we have to also consider some emerging threat as well for, I would say, from industry demand. For example, with AI, we have a big data center, right? And they use a lot of water as well. So we have to consider that. And we have the energy water nexus where we have the natural gas and nuclear expansion either for energy. That those structure, they use a lot of water. So you see that as we are progressing toward using much more technology, but we are using much more of that resources as well. Therefore, we have to come up with wiser management strategies and using less water to produce more crop, and also by encouraging equity and also in access disparity. For example, in rural community, if you look at in the underdeveloped countries, they don't have access to technologies and they face migration crisis because of water stress and they lack a lot of resources. And right now, there is other technology that people can use, like the solar panel, right? If you use solar panel that we call agri-voltaics, you have power, you produce electricity in your field, and at the same time, you can improve soil health because the sun doesn't hit the soil directly, improve your retention of your soil, and also improve the health of your soil. Of your That's a very good question because as you can see, there is a lot of research paper that has been published. There's a lot of predictions for the lab, and I think if all those technologies, all those breakthrough that has been done, they are done for a certain purpose. They have to reach the end user, and as I said, is intensive campaign of outreach and extension. So it's basically organizing workshops and also develop a website where we have all the information available. Because right now we have different informations about how to produce management practices to be used, but they are not easy to find. You have to reorganize them. And another issue as well, if we have to encourage growers to use to adopt those conservation practices, we have to also provide incentives Sometimes if we provide incentives to the growers that can help them, that can attract them to apply those conservation, because right now growers can use any technology using satellite data, but at the same time, sometimes there's some issue. If there is internet shortage, for example, the growers may lose satellite access, and that is an issue. So we have to decentralize the research, kind of conducting intensive outreach and extension campaign, and also organizing workshop. And one of the approach right now is not only creating the tools for the growers and policymakers, is to get feedback from them. It's basically co-creating those decision support system with them, because they have the direct experience with the tool that they are using, and they have a better understanding of the problems of the issue that they have. So when we go through, we discuss with them, they will say, this is what I need, this is our problem, this is what we would like to have and as a tool, as technologies. And then we can take those recommendations, come back to the lab and develop stuff. And after we develop those stuff, we can present them the results. So they will say, okay, that can solve my problem. And that may create another problem again that we as researchers we have to find solutions. But again, as I said, we we should not be the sole creation of those solutions. The growers, the all the stakeholders, the ad tech startups, they should be co-creator of that solution. For example, this platform agri-tech that can create some dashboard that help to manage farm. Later on, it can be integrated with evapotranspiration, with network sensors data that help the farmers to take better decision, not just about accounting, economics, but also environmental aspects. So the farmers can say, okay, if I should, based on my location, this is likely my soil quality, the water quality that I use, and if I grow this crop, this is the amount of money that I will be able to make while protecting the environment and complying with the policy and regulations. Yeah, for 2025, I'd say, in terms of global water management, and I'll say it's the emerging threats from industrial demands and climate change, because the climate, all the parameters are shifting. We have less snowpacks and we have less precipitation, and the farmers, they are having also, they are being allocated less water they used to have. And also, if we, I don't want to go into geopolitics or into market, but that's a big issue. That's a big issue as well. And also the environmental protections, it's still a big issue. Because of that, they still are coming with more regulatory pressure that basically in some areas that kind of force farmers to go out of business, for example. And some cattle farmers, because of nitrate leaching and they say, okay, we cannot keep doing that. And I think that we can use the technologies and style tools to monitor how we are dealing with the environment and help the farmers to use emerging conservation practices that help them to keep producing good food, but also protect the environment for the future generation.